Hi, I'm Kendra Little from Redgate Software, and in this series of videos, I'm going to talk about designing database changes for high uptime environments. First up, in this video, I'm going to talk about how do we measure DevOps performance. In my experience, DevOps techniques make a ton of sense when it comes to designing and shipping changes for high uptime environments for a couple of different reasons. First of all, DevOps techniques lend themselves to being able to ship a lot of small database changes. And as we're going to talk about in the patterns section, doing a lot of small changes is one way to maintain very high uptime and performance for critical systems. And we'll talk about why in that section. The other thing that I think really makes DevOps make sense for these critical environments is that DevOps is all about handling both the operational side of things, handling these concerns about how do we deploy without taking the system offline? How do we deploy without having user impact? How do we remove the potential of error from our deployment methodologies, which pairs really well with these critical systems? If we're doing DevOps, we have some really helpful tools as well. On this slide, we have some pointers about how, if we're doing DevOps, how do we tell if we're doing it right? And these come from the State of DevOps report in 2018 by DORA. And DORA is the DevOps Research and Assessment Group led by Dr. Nicole Forsgren. And in this, and also in the book Accelerate, Dr. Forsgren and her co-authors, Jean Kim and Jez Humble, talk about the fact that throughput and tempo, as well as stability metrics, are really key to keep an eye on when figuring out where are you at in terms of your DevOps performance and how can you improve. When we're looking at throughput and tempo, we don't just look at how often do we deploy. That is an important number, but it's also important to think about how long are changes waiting from the time their code complete to the time they're getting to production. In other words, what is the lead time for those changes? And this really is important in my experience. I have worked in environments where we were making changes to production every day. We're deploying frequently, but some changes would wait for months between the time the code was done and the time they got deployed to production because of very long testing and verification cycles. And this led to problems in stability. Let's say that we've shipped some of this code that's had a really long 2-month lead time, and we've got a question about it. We're not even sure there's a problem. There's just a question. Well, even figuring out the answer to the question can take the developer a very long time. They've been working on other stuff for a couple of months. They have to refresh themselves on why were we making this change? What exactly did we do? All of that stuff before even answering our question. And if there is an issue, this just gets harder and harder. So lead time for changes absolutely impacts stability. Deployment frequency can as well. If we're deploying infrequently, this can make problems with stability take longer to restore. And time to restore service, the time if there is something wrong in production to get making it right in production, is a critical stability metric, along with looking at, okay, how often are we causing problems in production? The goal of DevOps is to have not only a high tempo or throughput, but also to have a very stable system. And if we're keeping an eye on both of these metrics and rebalancing when things are getting, out in one area, when lead time for changes is getting high, if we look at that, figure out the root cause and figure out how to fix it, that will benefit our stability as well in the future. So it's well worth doing. And when it comes to doing this for database changes, the good news, if you're into authoring code for databases, the good news is we are going to need your skills for a long time. Because while tools and automation can really improve the ability for you to work with the system, these tools can't figure out important things that require your judgment and your experience. Because, for example, sharing successful coding patterns for database changes, you're actually probably going to have different needs in different parts of your environment. You're going to have some databases with really critical tables that need special handling, where it's really, really important to follow certain patterns. You're going to have other databases where it is far less critical and where you might be able to take some shortcuts and do less work because they have less customer impact and you don't have the same service level agreements around them. So sharing those patterns and also creating checklists to avoid pitfalls is really an increasingly important thing the more critical your systems get. These checklists are about things like, hey, we've got this table here. It's not a large table, but it turns out if you change the data in that table, that data feeds to a system downstream. And if we change things in this table here, it will cause very long data reprocessing times over there. Little facts and little gotchas like that about your database system. It's incredibly helpful if you have a specialist who helps find ways that people in the software development lifecycle can identify these while they are working on developing changes and learn about them right before this ever gets close to a change approval board if you do have a change approval board. Also, figuring out what is the best way to deploy our code. This is going to change over time. As new technologies emerge, we're going to have new opportunities and new options for how do we store our code in source control and what are the patterns that we use in deploying our code. So researching what is the best option for our team right now and keeping up with that and maintaining a really healthy language about the patterns we use and the automation we use is a very valuable contribution by a database specialist. Now this slide shows the compliant database DevOps lifecycle for software. And on the left of this slide, very, very key to all of this is having your code in source control. When it comes to authoring changes for high uptime environments, we absolutely need to be committing the code to a central repository so that we know what code should be in production and what is the history of that code, who has been changing it over time. This is very, very empowering and is the basis for all of the automation that helps us remove manual work. Removing manual work is for multiple purposes. Things like continuous integration, automatically checking our code to make sure that the code we have in source control can be built successfully. It is valid code for our database. That's something that, we don't want to do manually. It's just time consuming. We want a build to handle that. We also want a build to help us deploy to different environments, including production. And this is both to save us time, as well as to make sure that deployment is repeatable and it happens exactly. When we have humans at the keyboard who are pressing F5 or Control E, depending on your favorite flavor of execution, there is room for us to mess up. When we have an automated process and are able to do things like verify, hey, our deployment to a copy of production goes exactly as planned. We know exactly what it's going to look like when we hit production later. We have removed the chances of a lot of things going wrong. Now, looking at this diagram, you might just say, hey, we've got an environment with critical uptime, and we cannot just have things flowing straight to production. We want to shift as much review as we can left, but we do still have to have approval gating in place. Well, that is okay. This diagram, the arrows on this diagram do allow for gating and for approvals in here when you need them to happen. But like I said, you don't want those gates and approvals to drive that lead time for your changes up. You want to constantly be looking for ways to say, okay, if we're getting delayed on approval, what are the elements that we could do earlier that make that approval faster? How can we speed that part up through the life cycle? Now, on the bottom of this diagram, on the bottom right, you'll notice that it says monitor and optimize. Database DevOps, it is incredibly helpful if everyone involved in the change, not just ops, but also devs, have insight into production in a way where they can see, okay, here's where our change this afternoon was released. Here's what the system health looked like before the change and after the change. That visibility enables a feedback loop in this life cycle so that the entire team can understand the impact of changes, and it's very valid. We also want to make sure that we're regularly, for these critical systems, moving realistic but safe data sets back into the development environment. Having a realistic data set really empowers you to write better code. First of all, it helps you know, is your query actually working, right? If I'm writing a query that joins between two tables and I don't have data, how do I even know if it worked? But also, having realistic data sets helps me understand, does this query need an index? How should I expect, even roughly, performance to be on this given these data sizes and data distribution? But we do want to make sure that for sensitive data, for example, personally identifying data, we are able to mask that data or redact it, because we don't want to leave that data vulnerable in a development environment where it is just rife for data breaches. We want to make sure that we protect that data before we move it back into this life cycle. In the next video, we are going to talk about specific patterns for these high uptime environments and how you can author changes for high uptime. I'll see you then.